Hello, this is Kyle Welch with RCR Wireless News. I want to thank everyone for attending Network Visibility and Analytics Architectures for Next-Gen Mobile Networks, presented by Brocade. Our presenters today are Ravi Medikanda, VP and GM NVA Business Unit at Brocade, and Andrew Coward, VP Service Provider Strategy at Brocade. At this time, I'd like to turn the presentation over to Andrew.
Well, thank you, Carl, and good morning, good afternoon. So what we'd like to do is talk through today how we're really seeing analytics evolve through mobile networks, the requirements that are kind of starting to come out as a consequence of some fairly big changes that are happening inside mobile networks with consumers, with IoT, with all the things that are happening, and really talk about the visibility challenge. And so the topics we have today, we'll talk through the landscape. We'll talk through what mobile operators can really see today and what kinds of things they want to see kind of going forward. There's a lot of change in the kind of business requirements that mobile operators are seeing from analytics and what they want to do with the information, how that is supposed to enable them to act dynamically and in real time on what's going on in the network. And then we'll talk through the architecture, the implications of that change, and what that means to the network in terms of both gathering the information and processing it to affect real-time decision making. Of course, we'll talk through what Brocade is doing around this in terms of our network visibility and analytics platform and how we think we're leading the industry really in how we bring about this change. So let's kind of start by looking through the transitions that are kind of really going on. And living here in California as I do, kind of get the viewpoint that LTE is widely deployed, it's everywhere, and data's kind of ubiquitous. But actually that's not the case. And today there are something in the order of 2 billion smartphones capable of doing 3G or LTE. But there's another 5 billion that are not so smartphones that are out there. And what's interesting is it's predicted over the next 4 years that this will invert, meaning that through this time period, it'll be 5 billion smartphones and 2 billion less smartphones that are kind of left, not kind of upgraded to this infrastructure. So that's kind of placed a huge burden and is placing a huge burden on infrastructure, because obviously at the same time, the amount of data that's going through these networks is incrementing very, very rapidly. And most of the customers we speak to talk about petabytes of data flowing through their networks on a daily basis. So if that's kind of part of the problem here, that the sheer number of devices, and by the way, that's before we talk about Internet of Things, mobile to mobile, and the volumes of billions of devices that will bring, the sheer volume of data that's being generated, but also the fact that we're kind of shifting business models as well, from voice obviously to data. That happened a long time ago. The volume of data and the applications that ride over this network, both carriers' own applications, and now of course things like VoLTE, but also all the applications that are not theirs, that are OTT, that still need to be at least curated in some level. So for example, if customers are not having a very good Netflix experience, it tends to be the mobile operator that gets blamed rather than Netflix. Through this transition, we're also moving from a kind of hardware world to a software world, meaning that the transition from physical devices and appliances to virtualized software and NFV type functions, where everything from the EPC through to firewalls and load balancers and everything is being moved into software. And with that, the question really comes, how does data get collected in this new environment, given the huge amounts of volume that is going to be out there, and the fact that you can't reliably place what you would typically do with a probe in one place and expect the data from customers to kind of show up in that place consistently if it's now, the services are now somewhere in the cloud. Or to put it another way, you need to have the technology to collect data, the probes, if you like, either baked into the software that ships the standard around the network, or placed very close to that software so that as it moves around, as it gets provisioned, the collection of data is also provisioned at the same time. So some pretty big disruptions taking place here. So let's talk about what this means for network visibility. So a lot of time is spent by many of the network visibility vendors, and I've worked for them in the past, around what would today be termed kind of legacy services, but also solving problems that are now well understood. They still need solving, but the solution's out there. So for example, understanding drop calls, understanding coverage, understanding voice quality, things like that in networks. The drive testing that used to take place around to prove where reception was good or bad, the tools that were put in place, the packet generators that generated, all of those things are there and they work really well. But they don't provide a huge amount of visibility into what people are really doing with their smartphones today. And therefore, because the expectations of customers have shifted, the need to manage those applications, or at least understand those applications, have moved to the fore. So, for example, if you think about how networks congest and what that would mean in the old world with voice calls, where that would mean you just wouldn't allow new phone calls to take place, to today, where it would mean that a combination of users would receive poorer video quality or other services would deteriorate. Understanding what that means at an application by application level and being able to actually act on that data through policy begins to become important to maintain quality through this network. So where we see requirements therefore coming out of this world is against individual subscribers and understanding their unique experiences, understanding how the network and devices in the network are reacting to subscriber usage, the handsets themselves and what handsets are doing, how they're performing on the network, and of course location, understanding where traffic's coming from, and so on. Having been inside call centers in mobile operators here in the US and had calls come in, say things like, I can't use Facebook. How does that get diagnosed today? The care agent types www.facebook.com into their web page and says, yeah, I can see Facebook, it's probably working for you. Not an ideal diagnostic tool. So this need for visibility is clearly there and represents a growth and an opportunity within the industry. And by the way, it's not for a shortage of tools. In fact, for many carriers, it's a question of what new tools do they deploy. And we see a proliferation of tools and analytics engines that are kind of really being placed by different groups. And once they get to 10 or 20, it's kind of, they keep going. It's like, when did people decide that 20 was not a good number to stop at? They get to 21, they get to 30. And it's fascinating to watch this. But it also places an enormous burden on the network in being able to deliver essentially a copy of a packet to each of these tools to be able to go process this information. And so as more interfaces come along, S1, S10, S11, all these things need to presumably, by default in the world we live in today, have their own tools to analyze. When a new application comes along, it kicks off a whole new set of tools and so on, which may be good for the tool vendors, but isn't necessarily good for understanding the complete integrated kind of view of what's going on in the network. So our view is there's a different way of doing this. And so if you think about what happens in the network today and how we need to kind of move forward, there's a sequence of kind of products and functions that really kind of take place across this network. And there's a couple of markets, or there's a specific market that's really been generated over the past few years in what used to be just a simple tap. And that's the network packet broker. And the network packet broker's role is to basically copy packets. That certainly was a starting point. Interestingly, the role of a network packet broker now is to drop as much traffic as possible and only pass the relevant traffic to the relevant probe or the relevant analytics tool. And so the more sophisticated the network packet broker, the less information is generated from it or copied by it into each of the tools that kind of then downstream from it. So we've kind of moved from this simple world where a tap would be placed and every probe would get every copy of every packet to some very selective things. And Ravi will go into some more detail on what that means. So the probes themselves, as we said, need to start looking at subscribers, applications, devices, and some of them do. In fact, many mobile operators would argue there's no shortage of data. The question is whether they have the right data and how it's correlated. But in our view of the world, there's a couple of extra steps that really play out as things move to this NFV and SDN environment, and that's the ability to take KPIs, information that's generated in real time, and apply that back to the network through policy, and being able to orchestrate services based off what you understand to be the performance and usage patterns of the network as it currently stands. And then obviously that data feeds up into real-time and non-real-time engines that process business intelligence that then can go into other systems like mobile advertising and monetization, long-term planning, and so on. And we at Brocade see us play in this kind of role from being able to understand the packets at a packet broker level to being able to generate a lot of the information that's needed in real time off the network, put that in KPIs, and then push that out through technologies like OpenStack, OpenFlow, OpenDaylight, where Brocade's very heavily invested. So in this transition to software then, the central offices that were where traditional equipment has been typically deployed in carriers are actually kind of migrating their way into data centers. And this is becoming a realization, certainly here in the US, and the time that I spend in Europe certainly seems to be the case. And there was a view for a time that the central offices would actually get sold off because they were kind of prime real estate. And some of them will. But a lot of these places are being turned into data centers, or at least a smaller version of a centralized data center. And so what was typically proprietary hardware is now seeing common server technology and switches be installed to deliver services more closely to the subscribers, to enable caching, to enable collection of information, and so on. So essentially, a lot of the new services in a cloud sense are being delivered from data centers through the central offices into customers. An example of that is in Manhattan. I think some of the operators in Manhattan had a view that they'd be able to close down their data centers, close down their central offices and sell off that real estate. But it turned out that the most expensive prime real estate was also the places where financial companies wanted to connect because it gave them the lowest latency for all their services. And so that reuse of these central offices in this kind of new function, tied to the fact that a lot of services that will get deployed in this central office are software-based services, means that we kind of have to have the software that we put in a probe sense, in an analytics sense, follow this information around through these new areas. So from a business model perspective, certainly true that, and this is an NTT view of the world, I believe, from a couple of years ago, but it just shows that this transition to revenue has absolutely moved on to data. And so a lot of the questions that we get asked today relate to how different services compare against one another and how they're actually performing. Can you score how Skype runs over your network? Can you score how that compares with voice over IP services that might be native, or VoLTE services? And what does that really mean? So it's interesting that obviously carriers are still very voice focused when it comes to thinking about a lot of these things. But the same rules apply to all the video traffic that's being delivered through this network. And so as the business model shifts and as revenue shifted, the monetization of that data, the monetization of information has to follow, and analytics is clearly the way that needs to take place. So there are four kind of layouts then that we see as important to gathering information in this new world. Understanding not just subscriber usage, but who are the high value, low value subscribers, and where does what revenue does it represent? Looking at things like roaming customers coming into the network. They tend to be very high value for the time that they're on the network. And what does that mean? How do you ensure they get a good experience? How does different experiences affect iPhone users versus Galaxy users? And how many users are really upgrading through your plans versus going out and buying a product? So understanding that kind of handset piece is really important. Getting that data from the handset is kind of hard. And so being able to extract that information as it flows across the network becomes the kind of next best thing to getting it directly off the handset. At application level, understanding the applications and services, matching the demographic information you have from a big data perspective, and so on. A lot of the mobile operators we're talking to are spending time understanding congestion and understanding it as it transitorily happens across their network, the impact that generates. And then the question, going back to the SDN and kind of policy perspective, what do you do when congestion occurs? Other than plan for an upgrade at some point in time, can you, for example, stop tethering taking place? Could you transcribe video so it uses a lower bit rate? All of these things can play out when you have dynamic understanding of that traffic flow. And then from a devices perspective too, certainly it takes place with smartphones, but the proliferation of Internet of Things type devices. As an example, I drive a BMW. My BMW was automatically upgraded by BMW 2 days ago to avoid a security vulnerability that would allow somebody to break into my car without breaking into it, apparently, just by copying my key fob. That vulnerability is fixed, but for the presumably tens of thousands, hundreds of thousands of BMWs that are out there globally with a mobile connection, that was something that had to happen, and had to happen once and had to happen well, as that vulnerability was exposed to the industry. And so how we think about devices shifts in this new world, and we have to accommodate the network and the analytics around that to accommodate. So I'd like to hand over to Ravi now, who's going to talk through how the visibility of this really affects kind of the transformational change we see from an architectural perspective in the network.
Thank you, Andrew, and good morning, good afternoon, good evening, folks that have joined across the globe. My name is Ravi Medikonda. I'm the Vice President and General Manager of the Network Visibility and Analytics business at Brocade. And what I'd like to touch upon that following Andrew's discussion around the current state of mobile operators is the current transformation that is happening in service providers and the factors that are driving the transformation and what technology transitions are happening within these network architectures related to network visibility and what solutions and product portfolio does Brocade bring to the table and the strength of these open, agile, and software-based solutions that Brocade brings to the table. So first of all, we need to understand the fundamental transformation that's happening in the networking industry. Some of the factors and some of the foundations that the industry was built around building networks, transition from traditional TDM to IP through MPLS has been built with custom hardware and have long provisional cycles of turning up the platform, turning up the network. These are complex configurations. These are relatively difficult to scale, and every vendor that you build the network with has to develop a new custom platform. Some of the time they do develop new ASICs, and lack of agility. All of these are closed. If you would like a new feature, I have been with hardware vendors all my life. It takes 12 to 18 months to schedule, deliver it on the roadmap, and service providers cannot wait for these with the expeditious nature of how services are being delivered by over-the-top providers such as Amazon in case. So this transformation and the drivers of the transformation are well understood by every service provider. Companies such as AT&T have publicly announced their thinking and their vision of Domain 2.0, and so did every other service provider. The foundational blocks of this transformation starts with, hey, it has to be, every function of the network has to be a software function defined as virtual network function. And these VNFs, whether it is a routing VNF or in case of visibility and analytics, whether it is a probing VNF or whether it's an analysis VNF or whether it's a dashboard VNF, has to be software architected using software, architected so that it can run on commodity x86 hardware and hypervisors. It has to be open, so service providers can develop their own feature sets, their own reports, what's traditionally, what's now being called the DevOps model. So you don't rely on innovation from the vendor as opposed to building innovation in-house. And more importantly, any hardware that is necessary, and there's certain hardware that is necessary to replicate packets and at line rate, that hardware has to be programmable, which is typically synonymous with SDN. So just want to set the stage that this is the vision and this is the transformation vision coming from almost every service provider that we have been talking to. Leaning upon this vision, I want to talk about the visibility and some of the fundamental problems of visibility following the conversation from Andrew. So the crux of this slide is very simple. I did a search on Google saying mobile data traffic, and every graph that shows represents a hockey stick in particular. And today, Cisco released its VNI forecast, and essentially it says 1.5 exabytes of traffic per month originating from smartphones or originating into the mobile or traversing the mobile network. So just to keep in context, what is an exabyte? Exabyte equals 1,000 petabytes, and a petabyte equals 1,000 terabytes, and a terabyte equals 1,000 gigabytes. And typically when you go to a store, you buy a 2 terabytes. So essentially you're talking about 1,000 of those times 1,000 of those for an exabyte, 100,000 of those for an exabyte. Relatively, this is important as we transition to one of the fundamental problems with network analytics in mobile operators. So analytics is essentially crunching key insights on the of the traffic that is traversing your network. And I show this in 4 different stages. The amount of traffic that's traversing a service provider's network. Again, let's boil this down not to exabytes. Let's take one step down, petabytes on a monthly basis. So the subscriber traffic has to be filtered, has to be aggregated, and sessions have to be correlated. That reduces the amount of data to certain extents, and let's assume that's terabytes. And furthermore, this data has to be pre-processed by virtual machines, what we in Brocade shortly I'll describe to you what we call the VIPes, the virtual intelligent packet engines. So you don't need to process the terabits of data. You can just go down to the gigabits of data so that we extract the key metrics or key metadata from the packets. For example, the fundamental data plane in a mobile packet network is GTP. So when we parse the GTP headers, we see the IMSI, the MSI SDN, the attached location, so on and so forth. And furthermore, this pre-processed metadata will be reduced depending upon what reports, what metrics, what KPIs you want to generate. And finally, you pipe this into your big data farm and get reports, get analytics, get a dashboard, and all of those are pretty rudimentary. And there are a lot of open source tools that you could use to generate this. But the problem I want to highlight for generating mobile analytics, and a problem which compounds itself over time because of the nature of traffic is growing on a hockey stick format, is the data ingestion and the data reduction problem are fundamental to the architecture to build a visibility network. And subsequently, I'll show why vendors, service providers are throwing a lot of custom proprietary hardware to get through the data reduction problem, and what Brocade brings to the table in a way to reduce this and give you tools to help so that you can build your own dashboards. So the data reduction technologies have evolved over time. Previously, in the first generation, it used to be just passive network taps, which used to replicate all the data, and subsequently, there's a set of classical set of equipment that's called in its category the network packet broker evolved. This is essentially an intelligent, cost-optimized Ethernet fabric which does filtering, and most of the filtering that most of the packet brokers in the industry do is a static filtering. You filter by IP addresses, you filter by source destination pairs, and you filter by a port number. Beyond that, there is no intelligent dynamic filtering, which Brocade has just introduced, and I'll go through it, how it works. And session correlation and demultiplexing the field. So these are the technologies that have historically been used to reduce the data that's getting to the big data analytic form so that dashboards can be created, insights can be created to make changes in your network or to make business decisions. Two fundamental game-changing technology transitions that Brocade is introducing. One of them is dynamic SDN-based filtering. And why we call it SDN is based on the applications, based on the subscriber types, based on the device types, based on the network roaming information. So if you would like to filter out, for example, Netflix traffic, because you really don't need to analyze a huge amount of video traffic, the ability to filter the traffic at stage 2 is what the reprogrammability of the network packet broker, and these are some of the innovations that Brocade is bringing to the table. First game changer. The second game changer is these filtering and analytic tools are sold as custom hardware appliances ranging from north of 200,000, and traditionally, as you scale out, as the amount of traffic increases, as you install new cell towers, you need to go and rack mount, and there's a high cost structure in rack space, power supplies, bringing in new custom equipment, stacking bricks on top of each other. So service providers have realized this problem, and typically these are called probes, DPI boxes, so on and so forth. The second game-changing technology that is becoming a critical part of mobile analytics architecture is the ability to virtualize all the probing technologies and tools and deep packet inspection hardware platforms. These are the two game-changing technologies that are key in transitioning to what service providers talk about the network building blocks of tomorrow, and what Brocade is introducing in its NVA, network visibility architecture. So this slide essentially summarizes what I talked about. The current architecture, which Andrew talked about, has a lot of custom hardware sitting in mobile central offices. Progressively, these central offices are becoming data centers, racks and racks of x86 CPUs with virtual machines. So service providers need not plan for custom hardware, need not plan for additional power supplies, additional rack space. The ability to deploy probes on virtual machines, the ability to deploy probes on raw x86 blades is fundamentally the first NFV-based game-changing technology transition that is happening. And we are seeing this requirement from a lot of service providers. And secondly, the ability to reprogram your network ingestion logic, a combination of aggregators and packet brokers, so that you don't statically filter, but you have the ability to dynamically filter based on, hey, I do not want to see any XXY cell phones in my network because these are from X vendor who is not allowed to inject cell phones into this network. We can filter this on the network packet broker because we do have a logic of tracking the IMETs and IMEA numbers and associate that to a particular OUI, organizational unique identifier belonging to a particular hardware vendor. This is a classic example how to filter based on demand, not filter based on static IP addresses. Here is what Brocade calls the network visibility and analytics architecture. And this is based on the foundation of what the networking technologies and evolutions that service providers have mandated and have prescribed. Basically, software-based, running on commodity hardware should be open. The ability to reprogram should be agile, should scale out. These are the 5 fundamental attributes. And some of the building blocks of the visibility architecture components is, first of all, this is an architecture. What it means is you don't buy hardware platforms, you don't buy a particular solution set, you extract components of this architecture and build the application suite using DevOps model. The first and the foremost platform is the network packet broker. Brocade has the highest density, the lowest cost programmable network packet broker that is deployed by some of the largest mobile operators in the world, followed by a virtual router and a virtual firewall that can, on a policy basis, can reconfigure and filter traffic. And we do have a number of probes. As Andrew mentioned, there's a probe, there's a technology or interface such as S11, and the future might be an S12 or an S13 and an S14. So to keep up with the continuous innovation on the standards and the continuous evolution of new interfaces, we have virtualized the probing technologies and given APIs so service providers can develop their own decoders. For example, if you would like to incorporate a DNS decoder or DNS probe and you would like to write your own decoding logic, we have the APIs and we have the decoding interfaces to our virtual probing software that you could develop on your own without relying on a vendor to supply you expensive custom hardware. And on top of it, we do have the analytics platform, which is an analysis and correlation logic, which kind of makes sense of the metadata coming in from different parts of the network and give you insights that are meaningful. And based on that, you can create different use cases, which some of them are cell tower congestion use cases. You could look at a cell tower at any given instance, and we do have a logic. We give you congestion based on 5 stars, whether there is a lot of detaches coming from smartphones, which is the signaling messages, whether there's a lot of YouTube and video traffic hitting your cell towers, or whether there's a spectrum overlay and folks are not being ubiquitously spread among cell towers. So all these logics are represented in different stars, and we will give you these components so that you could use to build your own application. Same thing for new revenue generation logic and VoLTE monitoring. Most of all, the driver of how to instantiate these probes or these virtual probes and these analytic platforms, you never know when you need to scale out. And if the traffic is increasing, you need to plan for power supplies, rack space, so on and so forth. All of our virtual probe instances have REST APIs that can be instantiated dynamically based on need using OpenStack and or Open Daylight. So you don't need to pre-plan and pre-provision your probes. You can always do it on demand based on the incremental bandwidth or the incremental subscriber volume that is constantly increasing in your network. So I won't spend a lot of time. This is the MLXE platform. This is the SDN-based packet broker. The beauty of this platform is it scales. There is a form factor that is 4 rack units all the way to a full-fledged rack. So depending upon your mid-source or central offices and depending upon the scale needs, we can pick any one of this, and all of these are SDN programmable to cater to the needs of mobile operators, the ability to filter on an IMSI, MSI SDN, cell tower ID, the ability to filter on application traffic, the ability to filter on roaming traffic, the ability to correlate session traffic, the GTP session traffic from 3G and LTE networks, the ability to load share among different GGS and SGSN pools. All of the logic is built into the MLXE platform. And these are the structural components of our virtual analytics platform. This technology came from an acquisition called Vistapointe that Brocade acquired 2 quarters back. And I personally came from Vistapointe. The 4 foundation blocks are the virtual machine components that constitute the analytics platform. One of them is the VIPE, what is traditionally known as virtual probe, which I have indicated is an open platform that service providers can develop their own decoders. We have the framework, so you don't need to wait for a vendor to develop an S12 or an S13 interface or whatever is being developed in the industry. We give you the open API so that you can develop your own decoders, decoding technologies, whether it's DPI or any 3GPP protocol parser from diameter to radius, to S6A, to S11, to S1U, to S1MME, and so on and so forth. And we do have all of these shipping today. And these can be run on x86 platforms, some of them, and some of them can be run on virtual machines. The analysis and correlation engine is essentially a master, a scalable and scale out data mining engine that correlates data on the wire, the metadata that the VIPE spits out to data at rest, such as the cell tower knowledge base, the subscriber rate plan knowledge base, so on and so forth, and gives you the ability to create adequate reports using the GRE or the generic reporting engine tools. And a subset of this is the VICE or the intelligent SDN engine, What the ways essentially constitutes is a near real-time control plane of your complete mobile network. Since the Waze has metadata and insights from S1MME to S1U to S11 to S6A to GX to GY, and you don't need GX, GY, and S6A, you just need one of them, you could correlate the complete 360-degree complete view of the network in terms of attributes, from subscriber attributes to application attributes to roaming attributes to APN attributes to MSISDN attributes. And having this near real-time information gives you the ability to develop an SDN programmable engine that can talk to several platforms. Today, the Vice SDN engine interoperates with Brocade MLXC platform, the packet broker platform, and the Viata firewall and the virtual router platform. And we are working with other routing and switching vendors to open up their interfaces. And finally, we have developed a great visualization tool, which is a graphics engine which runs on a separate VM and it has open interfaces. And if you just want to use a graphics engine, and I'll take you through a few screens of how versatile and how much design that we have incorporated into this. So these are the Vistapointe analytics portfolio that constitutes the architecture that Brocade has for network visibility and analytics. Here we do show some subsequent building blocks of each one of the portfolio, the Vibe, Waze, and Vivid. And this is typically a deployment model. On the left-hand side, you see a typical mobile network all the way from cell towers to the mobile packet core, the SGSN, the S-gateway, P-gateway clusters, through the HSS, MME, and PCRF clusters on the right side, and different interfaces in the mobile packet core, such as in this case the S1MME, the S1U, the S5, and the SGI are tapped using passive optical taps. And this information goes to the network packet broker, which is reprogrammable, as I indicated, which does the most important function, such as reducing the amount of traffic and correlating the discorrelated traffic. And this information is sent to different vibes depending upon the protocol decoding necessary. And these vibes spit out the metadata, and on a configurable 10-second to 30-second to 60-second window, depending upon your needs, you could real-time stream these into the analysis and correlation engine. Or if you are a service provider, you have your own big data engine already running, you could use all of these are open. We are not tied like other vendors where you need to buy both ends of a probe and the dashboard. All of these are open. So if you have your own big data engine and you're looking for a data sourcing components which are virtual, which are open, and which are software based, you could take the solution components from Brocade. And finally, the Vivid is also a graphics engine that's open, and you could use it with your existing big data engine. And as I indicated, one of the fundamental values that we bring to the table is, as a service provider, you don't need to plan and you don't need to wait for provisioning additional probing infrastructures. Using OpenStack APIs and RESTful interfaces on the vibes, you could instantiate new vibes on demand. As the traffic increases, and as we talked about, traffic is only increasing in the mobile network because we're all consuming from our smartphones. And as Andrew indicated, the smartphone population is going to increase from 2 billion today to from 2 billion to 5 billion. And there's a, there would be a continuous need to increase the data sourcing engines or protocol parsers or probes. So we don't see the need for deploying custom proprietary expensive hardware. There is a way out of this: software-based probes, OpenStack-based instantiation, so things can be automated. So finally, not to delve upon this in detail, but there are a number of use cases that you could generate by using virtual probes and the dashboard, and all of these use cases are programmable using the DevOps model. One of them is the analytics offload, the ability to ingest and reduce the amount of data that's hitting the probes. And a classic example, and a couple of service providers have told us that, hey, we know what comes in YouTube. We have no reason to filter YouTube as long as we know someone is using YouTube. So how do you do that? How do you know a particular IP address is assigned to a particular smartphone, and this smartphone is using YouTube, and you have to filter this traffic based on these IP addresses, and these dynamically change? We have the logic that's tied to the SDN programming engine on the MLX that would be able to dynamically do that. Same thing, if you don't want to monitor Apple iPhone 6s, assuming everything is running fine, we have the ability to do that, so on and so forth. The second use case, what is a typical favorite for most of the CFOs, is the roaming leakage, because most of the revenues are tied to roaming. Most of the incremental revenues, are tied to revenues, roaming revenues, and there's also a discrepancy some of the times when you exceed your data plan because of the signaling traffic misses. The reconciliation on the packet gateways and the GGS and infrastructure to your billing systems, the offline charging, the online charging, the reconciling and the KPIs are not accurate. So if there's signaling errors, if there are KPIs that don't reconcile, we have a dashboard that shows, hey, your roaming revenue should be accounted at 2 terabits, but however, you're only seeing 1.6 terabits worth of roaming revenue. We do have the ability to show you a dashboard where you missed it, where are the signaling errors. While it sounds simple, rudimentary, this is where the CFOs allow to identify the revenue leakages in instances that I talked about. Similarly, new revenue generation, and I'll talk through a few examples of new revenue generation. In interest of time, I'll browse through a couple of depictions of our dashboard. So this is a dashboard of how we depict the subscriber analytics. In a couple of things is you could look at cell towers. Depending on the load of cell towers, they turn from green to yellow to red, and they dynamically index based on the number of GTP tunnels that are attached. Here you can see how many users are roaming inbound, how many users are roaming outbound, how many users are prepaid, how many users are postpaid, how many users are within each rate plan. This is the master view of our dashboard, which is designed to work on tablets and phablets and touch screens. And we use simple context for each and every screen, which is subscriber view, application view, network view, or device view. Here in the network analytics, we drill down into APN. So if you are a mobile operator and have several APNs, each APN dedicated to a virtual mobile operator, you could see on a 5-minute interval how many subscribers are traversing your network originating from the MVNO. And you could see this on the right-hand side, who is roaming inside your network, from which operator and which country, and how many users are roaming inside your network. This is the application analytics. Some of the insights here in the last half an hour, what are the top 10 applications that are riding on the cell towers that you zoomed into? What's the number of users? What's the usage in megabits? And how long has these applications been hitting this packet core, or these cell towers aggregated into the packet core? What are these protocols? Some of these protocols are non-identifiable, such as BitTorrent and Skype and SMTP and SNMP. We also groom them per APN, per RAT radio access type, whether it's a 3G cell tower or an LTE cell tower or an edge cell tower. And we also get a view into devices. What are the different devices proliferating in your network? What's the iPhones, iPads, so on and so forth. And Here we give you a view of cataloging. I mean, this is a very interesting view. If you want to look into what devices are cataloging inside your network, so on and so forth. This we have a view that we give you on tethering. In the interest of time, I'll skip through these. And most importantly, we do realize that operators come from different countries and globally. And on a click, this is a multilingual, I-18 and ready, which means that on a click of a button, I can change it from English to Japanese to Chinese to Vietnamese to Spanish, and every screen shows the local language. This is a depiction of our dashboard, and I'll quickly wrap this up in a minute for any Q&A, Kai. So some of the new business models that are driven from analytics, such as in the connected car, the ability to understand the different mechanics within a car and populate it back to the mechanic shop, the ability to have over-the-top applications such as Skype such as Netflix to sponsor your data, and how do you identify who's using Netflix so that you don't pay for it? Netflix sponsors it with AT&T, for example, and we do have a function called search engine cleaning, so we can figure out who is searching for, let's say, a Nike shoe, and if they're sitting near a shopping mall, we can give you those kind of insights. And progressively, as we get to Internet of Things, this is a great tool and dashboard to monitor trucks and air conditioning systems, so on and so forth. Essentially, in summary, Brocade has assembled a great portfolio of products. The packet broker, which is the highest density in the market with the lowest total cost of ownership. Analytic portfolio of software components from wipes to Waze to Vivid to Vice to a Viata virtual router that scales out on your existing virtual machines and x86 platforms. And most importantly, we have developed all of these with open APIs in mind. So these can be programmable, and you can create your own application using the DevOps model. Stating that, I'll stop, and I'll give this session back to Kyle for any Q&A.
Thanks, Ravi. Great presentation. We've had a few questions come in only a few minutes, so we'll just jump right in. Both Andrew and Ravi, feel free to comment on these as you see fit. Anyways, the first question we got in, what is the relevance of Brocade in mobile operators and analytics?
You take it, right?
Yeah, great. So let me take the Andrew. So first of all, yeah, that's a great question. So Brocade MLXE, which is different from the MLX routing platform, has been deployed in some of the largest mobile operators. Let me repeat it. The largest mobile operators as the network packet broker platform. So historically, they have presence, they have incumbency, they know this architectures inside out. And more specifically, over the last 2 quarters in 2014, Brocade acquired Vistapointe, which exclusively focused on software-based technologies, virtual probes, virtual analysis and correlation, and SDN reprogramming engine. So with a combination of this, Brocade is very well front and center of mobile analytics and insights and technologies that operators need.
Yeah, well, to put it another way, when mobile operators get volumes of traffic that mean they've got multi-hundred gig links of mobile traffic needs to be analyzed, then we come into the picture. When they need to virtualize their network services and they want analytics to go alongside that, then we come into the picture. When they need a view of analytics as it relates to applications and devices, then we come into the picture.
All right, great. Kind of a follow-up to that we got in. So in regards to the adoption curve for analytics, where are service providers and MNOs today on the NFV SDN adoption?
Yeah, so through the course of last year, there were a great many POCs, and indeed Brocade is in over 40 of them with tier 1 operators around the world. And what we're seeing through this year is them kind of move out of the labs into the first field deployments. These aren't not huge. We're not seeing millions and millions of customers move across. We are seeing thousands of customers in the first instances of these services begin to get deployed. So we're kind of on the cusp of what's going to be really a mass migration to these new base services. That's on the NFV side. On the SDN side, it's more application specific. So we're seeing SDN being used alongside existing networks, existing technologies to look at and control specific things, be it an optical network, be it understanding distributed denial of service attacks and being able to make decisions about traffic based off the flows that you see. So those things are being deployed where it makes sense across the network.
Great. The next question we had come in, does NFV and SDN-based technologies have any revenue impact, or does it only affect CapEx?
Ooh, that's a good question.
You want me to take that? I have.
Go first.
So that's a great question. So first of all, that's actually a misnomer. The NFV in particular and SDN coupled with that is primarily driven for lower cost of CapEx or lower cost of operations. That's just a starting point. Obviously, the cost control is the big thing that every operator looks at, but agility and the time to provision and get new services up and running, right? That's fundamentally what NFV and SDN brings to the table for service providers. The ability to automate, the ability to get new services up and running much faster than what they have been used to is the primary driver for that.
But I think what a lot of service providers are coming to realize is that they have to have a kind of user impact. So yes, it can save CapEx, and certainly expect that. It should save operational costs, particularly if it's done together with a DevOps model, which many operators are wanting to move to. But if it doesn't do something unique for the user, then it kind of has no incentive for these to migrate to the new service or adopt. And in our view of the world, from a Brocade perspective, we're looking at what that impact means from an end user perspective. And we think one of the key ones that NFV can bring is that it enables every customer to basically be given their own network in a very unique way. So because you're able to allocate unique virtual resources to that enterprise customer, to that user, they're able to then modify their experience, meaning modify what firewall rules they use, modify how their traffic is managed across that network uniquely to them without fear of upsetting other users on the network or other systems on the network. And that's exactly how we've seen it play out in the cloud service providers like Amazon and Rackspace, where you can go buy a Viata instance today online.
All right, I think we have time for just about one question, and then our panelists today will get a list of the questions we didn't have a chance to get to. So to close it, how does the architecture discussed today scale towards large numbers of small cell, nano, and pico base stations?
Yeah, so that's a great question. So it's also something that's very pragmatic in terms of how the networks are being scaled, because LTE doesn't mean there's a magic spectrum and you can blast a huge amount of traffic. LTE essentially means you kind of divvy up the cell tower logic, the coverage into smaller cell towers, and you have a better bandwidth capacity. So whatever the pico cells, the nano cells, or the LTE small cell coverage means that this evolution is happening, and this is fundamentally increasing the total number of connections going into the mobile packet core, therefore increasing the total signaling traffic into the mobile packet core. So as I indicated, every technology that is adaptive and that increases the signaling traffic brings together a lot of traffic on these S1 MME interfaces. And we are this software-based approach, as you increase the number of last mile connections using small towers, you don't need to go to a probe vendor and place orders for more S1 MME probes and increase the scale. So this is a great example, right? How you can dynamically instantiate new instances of the S1 MME probe as your cell tower concentration increases and builds new connectivity to the packet core. And this is one problem that came in the form of a question, and this compounds itself in several other areas in the network, right? As different P gateways are virtualized, there's a technology called virtual EPC. Do you need to develop new probes, or do you need to reprogram your probes, or do you need to develop new decoder for your probes? So this technology, which is virtual and open and developed on top of Linux and works on top of virtual machines and x86 platforms, is programmable, extendable, and fits perfectly to the question that was asked. The ability to scale and support large number of small cell towers and base stations, pico base stations.
All right, thanks. That's about all the time we have today. I want to thank everyone for attending Network Visibility and Analytics Architectures for Next-Gen Mobile Networks, presented by Brocade. Again, our presenters today were Ravi Medakanda, VP and GM, the NVA Business Unit at Brocade, and Andrew Cowan, VP Service Provider Strategy at Brocade. Thank you, everyone.
Thanks, Carl. Thank you, everybody.